Good morning and welcome to today's webinar where we're going to be talking about carbon. My name is Paula Wallace and I'm the Specification Manager here at saveBOARD. Today we've also got online Paul Charteris, who is the CEO, and you're in great hands because Paul will be answering any questions that you might have. Please use the Q&A to ask questions, or also the chat function is turned on if you'd like to send any feedback or make any comments. You can also submit reactions if you get the urge to do so. So, the agenda for today. We're going to look at what is global warming potential and how is it assessed. Then we will look at what is biogenic carbon. And then we will compare the carbon footprint of some common building materials, primarily looking at internal wall linings and rigid air barriers. So we've still got a couple of people joining in there. I can see that ticking over. So just to recap, looking at global warming potential and how it's assessed, what is biogenic carbon, and then comparing the carbon footprint of some common building materials. So first up, global warming potential. So what is global warming potential? And that is also often referred to as GWP. It is a standardized way to measure the greenhouse gas emissions associated with the full life cycle of a product. So the full life cycle includes the extraction of raw materials, manufacture, distribution, installation and deconstruction, or what happens at end of life for the product. Global warming potential is also often referred to as embodied carbon. So now we're going to look at how is global warming potential assessed. So in an Australasian EPD, the assessment of the GWP takes into account the fossil indicator. So fossil calculates the emissions created by fossil fuels. The biogenic indicator accounts for the amount of CO2 or carbon dioxide that is taken out from the atmosphere, and also land use and land transformation. Now, this indicator takes into account the emissions that are created through the use of land or by changing the land. Today, we'll use the same number across all of our comparisons, and I'm going to use the total global warming potential being the sum of fossil, biogenic, and land use / land transformation. And then we will also just focus on the A1 to 3, which is commonly used as a reference. And it is also known, A1 to 3 is also known as the cradle to gate, which a lot of you will be familiar with. So to recap on our numbers, we are using total global warming potential A1 to 3, including biogenic carbon, and the unit of measure is per square metre. So we are going to look at what is biogenic carbon. And then we're going to look into where the biogenic in saveBOARD products comes from. So biogenic carbon is the carbon that is stored in biological materials, such as trees or soil. And through the process of photosynthesis, you're going to have to crank back to your biology high school class there. Through photosynthesis, trees are taking climate warming carbon dioxide out of the atmosphere. Wood-based products that are made from trees are storing this carbon dioxide that has been taken out of the atmosphere. If the product isn't destroyed, the carbon dioxide remains stored. And that's the reason why timber products are better for the environment than, say, steel or concrete products. Timber products are storing the CO2 taken from the atmosphere, whereas in the cradle to gate process, say A1 to 3 of manufacturing concrete or steel, this is creating a one-way release of CO2 emissions into the atmosphere. So very simple recap, biogenic carbon is carbon that has been sequestered and stored as CO2. So up next, where does the biogenic carbon in saveBOARD products come from? So the recipe we use to make saveBOARD is 60 to 70% composite packaging, depending on what product that we're actually making. It also includes soft plastic and end of life and offcuts of board. And actually our next webinar talks about circularity and creating circularity. So if you're keen to join us, that's up in a couple of weeks. Tune on in. So 60 to 70% composite packaging, soft plastic and recycled board. The finished board also has a recycled paper back. So the biogenic carbon in saveBOARD products comes from the composite packaging and the recycled paper back. These are paper products made from trees which are storing carbon. And now we're going to look at some numbers. So these are our numbers based on our CPD. Our CPD is finalised but currently being verified, so it won't be published for a couple of weeks. It's coming up in the next few weeks, publication. So for our comparisons, we will use the same benchmark today. So I'm going to use the total global warming potential, cradle to gate, A1 to 3. It includes biogenic carbon, and the unit of measure is per square metre. So saveBOARD bed brace, which is a rigid air barrier, minus 5.51 kilos of CO2 per metre square. Paper face, which is an internal lining, minus 4.31. Exposed is also an internal lining, minus 7.36. Ceiling tiles, which are made from exposed, the same, minus 7.36. Multi-use, which is a hoarding or industrial wall lining product, love this one, minus 10 kilos of CO2 per metre square. And then our roof board, a roofing substrate, minus 7.35 kilos of carbon or CO2 per metre square. So we're going to this slide here, we're looking at a comparison between common building materials, internal linings. So for transparency, the numbers that I've got here, we have taken from supplier published EPDs. So multi-use coming in at minus 10, exposed minus 7.4, paper face minus 4.3, untreated plywood, which is great, minus 7.3, and plasterboard at 2.64. So the savings per square metre of product, if you were looking at a multi-use instead of using a plasterboard, for example, you would be saving 12.64 kilos of CO2 per metre square. If you were to use multi-use instead of untreated plywood, you'd get a saving of 2.7 kilos of carbon per metre square. So these next slides are a look at some, say, real life project examples. So this is a garage, and we have done the numbers based on 60 square metres of product, of wall lining, and we are looking at using exposed instead of plasterboard. So in this instance of 60 square metres, the carbon saving would be 602 kilos. And I do love a fun fact, so I've had to add one in. The waste diverted over that 60 metres square would be 420 kilos. Another example based on a commercial space, the application here is 200 metres square of product and it is used as an industrial wall lining. And we're looking at using multi-use versus plywood. The waste diverted, which is an awesome fun fact, 2,139 kilos would be diverted from a New Zealand landfill if you were using 200 square metres worth of multi-use. The image there with the green, that is multi-use with a LDPE face, which we use on all of our product. We can use clear or we can use a colour. So this is a custom colour that we have done in the green for Woolworths, and there's a big range of custom colours that you're able to use to create a brand colour with multi-use as the board. So now we're going to look at a comparison using rigid air barriers. So here we have saveBOARD batter brace coming in at -5.51, a 7mm EcoPly at 0.93, 10mm Weatherline 2.64, and a 6mm James Hardie Rab 6.43. And so here, if we look at using batter brace versus a 6mm Rab, the saving per square metre would be 11.94 kilos of carbon or CO2. If you were to use batter brace versus a 7mm EcoPly, the saving per square metre would be 6.44 kilos per square metre. And so on this example here, I have used a 130 square metre transportable home, which is using approximately 160 metre square of rigid air barrier. If we compare a batter brace against a 6mm Rab, the total carbon saved on this project, 1,994 kilos. And the waste that would be diverted from New Zealand landfill, 1,421 kgs. Great figures. So next we're going to have a real quick look at where the environmental benefits of saveBOARD can be applied when you're looking to gain a environmental accreditation such as Homestar, Green Star. So Homestar, EN2. So as of July last year, it's now a requirement that all standalone homes calculate and report on their embodied emissions under EN2. EN3, you've got 10 points are available where at least 50% of the material content is reused, eco preferred or responsibly sourced materials. We're all over that. And EN4, construction waste minimisation across the project. For Green Star, credit 19, life cycle impacts. And then on credit 21, you can only claim one of these credits per product. Even if the product, in our instance, for example, fits the criteria for all categories, you can only claim against one of those categories. And then credit 22, of course, construction and demolition waste. saveBOARD products can also be used for a Living Building Challenge project because they have a declare label. So that is us. We are to time. Thank you so much for joining us. And just a reminder that our next webinar is Creating Circularity, and the invite for that will go out in the next week. And we will look to host that within the next 2 to 3 weeks.